Hello. In this section, we're going to be comparing two sample means and running hypothesis tests on the comparison of two means. So we're going to start off with means, of course. So there is, again, a Z and a t-test version of them, still based on the N. Now, I wanted to help you build the hypotheses so that you can see what they're going to look like. I'm going to let sample one be the prices or average cost of washers at Best Buy. I'm going to let sample two be the average washers at Sears. All right. So in comparing the two means, whatever sample is described first or given to you first, that's always sample number one. The second one described or given to you is sample two. So on this one, if I made a statement like the average cost of washers at Best Buy is less than the average cost of washers at Sears, you would put your symbol in, but then in the hypothesis, it has to appear a little bit differently. I'm going to need you to move the mu sub 2 over so that your hypothesis ends up looking like mu sub 1 minus mu sub 2 is less than 0. That's exactly the same thing, but you moved the mu sub 2 over to the other side of the equal sign. And that means that our H sub 0 would be that mu sub 1 minus mu sub 2 is greater than or equal to 0. That part hasn't changed. What if I made this statement, and again, we're still going to say that sample 1 is Best Buy and sample 2 is the average cost of washers at Sears. What if I said that I believe that they are different? They're different. That's not equal. They're not equal to each other. They are different. But again, in writing the hypothesis in a two-sample mean test, you would write mu1 minus mu2 is not equal to 0. Likewise, the null hypothesis would be that mu1 minus mu2 is equal to 0. This is how your hypotheses should appear. In one more quick statement, average cost of washers at Best Buy, average cost of washers at Sears. I believe that the average price of washers at Best Buy is no more than the average price of washers at Sears. Well, no more than is less than or equal to. So again, in order to write that as in a hypothesis, it would be mu1 minus mu2 is less than or equal to 0, which would make our alternative that mu1 minus mu2 is greater than 0. So again, same symbols are involved, just the way that you build the hypothesis is a little different. So let's start with the z-test. With the z-test, the formula that's going to be used is x bar 1 minus x bar 2 minus mu1 minus mu2 all over the square root of the variance of the first sample divided by n sub 1 plus the variance of the second sample divided by n sub 2. I wanted to highlight a couple of things. The letter out in front tells me the table that's being used, that's not any different than it was before, but this reminds you what goes into the hypothesis. Another interesting fact is that the mu1 minus mu sub 2 always equals 0. If you look back in each of the null hypotheses, it does say that mu sub 1 minus mu sub 2 is at some point equal to 0. And so that's what you actually use for that portion of the formula. Another way to know that it is going to be a z-test is that both samples must be have sample sizes. Both samples have to be greater than or equal to 30. So I can write that out to the side on this just to help me while I'm learning it. But it's exactly the same as in our single sample test. N1 and N2 must both be greater than or equal to 0. All right, so let's get started. With our first example, they actually listed the information for us. That is not required or guaranteed that they're going to give us anything. It may be written out in statements. We'll see examples like that in just a little bit. So I'm going to start. A high school principal claims that her students do better on a college entrance exam than any other school in their area? Okay. A sample of 50 students from each high school is taken. Is the principal's claim valid at a .05 level? So right now I know that alpha is .05. I also know that her students were mentioned first, so that is sample 1. That makes the other school sample 2. Now, she's comparing the average college exam score of her students to other school college exam scores. So, let's see. She claims that her students do better. On a test, doing better means it's larger. So that is the hypothesis that's being made. So I'm going to build my hypothesis test. Let me scoot it back a little bit. We're going to need a null hypothesis, an alternative, a critical value, an obtained value, and a conclusion. The claim being made is actually building my alternative. mu1 minus mu2 will be greater than 0, which means that my null will be that mu1 minus mu2 is less than or equal to 0. Now, I know that the only one we've looked at right now is a z-test, but you would also know that it is a z-test because both ends happen to be greater than or equal to 30. This one is an upper tail test. So we're going to start off by finding that critical value. Because it's a z-test, again, our ends are bigger than 50, I'm going to start by putting my alpha into the shaded area, which means this is 0.45. Luckily, this is our one of our ties, which we've seen often, so I won't go through the whole thing, but it is 1.645. The obtained value comes from the formula, so I'm going to plug in x bar 1 minus x bar 2 minus mu1 minus mu2 will always be 0. Some students don't even plug it into the formula. I like to, even though I don't technically put it in the calculator. All of that is going to be over, let's see, they gave me the standard deviation, so I'm going to square it to make it the variance over n sub 1. Plus, I need sigma squared again. They gave me just a standard deviation, so I'm going to square it myself. It will depend. If they gave you variance, you just put the number in. If they gave you standard deviation, you square it. Now, I put that into the calculator, and pause the video if you need to. I got 1.817 when I did it before. I'm going to plot that answer. Oops. Her critical value, first of all, was 1.645. So when I plot the obtained value, 1.817, it falls into the shaded area, so I'm going to reject the hypothesis. Because we're going to reject the hypothesis, I don't accept the h sub 0. I'm going to write what this guy says. Now, to be able to write what he says, you actually take it back into this format. You would move the mu sub 2 over to the other side. And now I can say, you know what? The average college entrance exam scores of her students is higher than other high schools. The average college entrance exam scores of her students is higher than other schools. Let me try to get one more example in this video. Our second example, is there a difference in the mean test scores for these two classes? Tested an alpha of 0.01, so I know alpha. And they listed them here, so I'm going to go ahead and assume that the first one is sample 1, second one is sample 2. Is there a difference in the means? That means when I compare the two, is there a difference? Are they not equal to each other? That's giving me the alternative, so let's build our hypothesis test. We're going to need a null, an alternative, an obtained value, and a conclusion. Now, the claim that was made, when I moved the mu sub 2 back over to the other side, I'm going to end up with the alternative. mu1 minus mu2 is not equal to 0. That means that the null is that mu1 minus mu2 is equal to 0. And it's a two-tailed test. Both of the n's are also bigger than 30, so it is a z-test. Two-tail. I'm going to go ahead and put the half of the 0.01 in each tail. So I get 0.005 in each tail. That happens to be our second tie. It is equally close to two scores when I look at the 0.495. So I handled the tie the way we learned in class, and we get 2.575 and negative 2.575. This one is a plus and minus because it is a two-tailed test. And now we'll find our obtained value. The obtained value always comes from the formula, so I'm going to plug in x bar 1 minus x bar 2 minus mu1 minus mu2, which is always 0, over, and again they gave us standard deviations, so I'm going to have to square them myself when I put them into the formula. I put that into the calculator, and the score I got when I did it before was negative 1.036. Negative 1.036 falls about right here. That means we're going to accept the hypothesis. So I agree with this guy. But remember, in order to be able to write what he says, you have to move the mu sub 2 back over to the other side. So I need to say this. I need to say mu1 is equal to mu sub 2. Remember, you're looking for the to see if there's a difference in their mean test scores for these two classes. So you're going to be able to say the mean or average test scores for class A and class B is the same, or are the same. All right, I'll see you in the next video.